Hi student, my name is Professor Prakash Vasankar. Welcome to my YouTube channel. Today we solve problem on differentiation from mathematics part second. Exercise 1.1 page number 12 page number 12 and first problem is on page number 12. Problem number 1 is find dy by dx if y is equals to cos x square plus a square. This is the first problem from exercise 1.1 in board book exercise 1.1 page number 12. And first problem is find dy by dx if y is equals to cos x square plus a square. That is here differentiate these functions. And that function is y is equals to cos x square plus a square with respect to x. So here y is equals to cos of x square plus a square. Then differentiate both sides with respect to x. Then we get here dy by dx. So first we write here the given function. And a given function is y is equals to cos of x square plus a square. This is the given function. Differentiate both sides with respect to x. Differentiate both sides with respect to x. Therefore, here ddx of y, so write dy by dx is equals to ddx of right hand side functions, and we write here the right hand side function is cos of x square plus a square. So we write here cos of x square plus a square. Therefore, dy by dx, which is equals to ddx of cos of x square plus a square. Now that ddx of cos fx minus sin fx into f dash of x. And here fx replaced by x square plus a square. Again, we repeat this formula. We use here the simple derivative formula. ddx of cos fx, which is equals to minus sin fx into f dash of x. And fx replaced by here x square plus a square. So we write here minus sin x square plus a square. So write this x square plus a square, x square plus a square into ddx of x square plus a square into dx of x square plus a square. That is here we use the formula ddx of cos fx, ddx of cos fx, which is equals to minus sin fx into f dash of x. Therefore, here this dy by dx is equals to minus sin x square plus a square up to this step as it is. So we write here ddx of minus sin x square plus a square as it is. Into here we use the addition rule. Here we use the addition rule and find out ddx of x square. And ddx of x square, when now that ddx of x square is 2x. By using the formula ddx of x to the power n x to the power n minus 1 plus, so So we write here plus ddx of a square, and here e is constant, therefore a square constant. Therefore, ddx of a square equals to 0. Because we know that the formula ddx of k equals to 0, where k is constant. Therefore, here ddx of a square, which is equals to 0. So, right here 0. Therefore, dy by dx, so right here dy by dx is equals to minus sine x square plus a square up to this as it is. So, write this as it is 2x plus 0, that is 2x. So we write here 2x 2x plus 0, that is 2x into minus sine x square plus a square. So we get minus 2x into sine x square plus a square, and this is the required derivative of the given function, and given function is y is equals to cos of x square plus a square. In this way, we solve the first problem in exercise 1.1, page number 12. In exercise 1.1 on page number 12, we solve here the first problem, and the first problem is y is equals to cos of x square plus a square. By differentiate these functions with respect to 2x and find out the dy by dx, and here dy by dx is minus 2x into sine x square plus a square. So dear student, if you like my video, please subscribe my channel and press on bell icon. Next, problem number second. On the same page, that is the page number 12, we solve problem number second. Again, in this problem, we find dy by dx. So here, find dy by dx, find dy by dx if y equals to, here y is given, that is the function is given, and function is here under root e to the power e to the power 3x plus 2, 3x plus 2 plus 5. This is the given function. And here we find dy by dx. Means here y is equals to under root e to the power 3x plus 2 plus 5. And we differentiate these functions with respect to dx and find out dy by dx. So first we write here the given function. This is the given function. We write these functions here first. This is a given function. Then differentiate both sides with respect to x. Differentiate both sides with respect to x. Here differentiate both sides with respect to x. Therefore, here ddx of y, so write dy by dx, dy by dx, which is equals to ddx of right hand side function, and here the right hand side function is under root e to the power 3x plus 2 plus 5. So write these functions here. Therefore, here dy by dx, which is equals to, I find here ddx of under root e to the power 3x plus 2 plus 5. And for finding out the derivative of these functions, we use the simple derivative formula. We know that ddx of under root fx, 1 by 2 under root fx into f dash of x. And fx replaced by this term, that is e to the power 3x plus 2 plus 5. We use here the formula ddx of under root fx, 1 by 2 under root fx into f dash of x. and fx replaced by e to the power 3x plus 2 plus 5. So we write here 1 by 2, 1 by 2 under root fx. So here under root e to the power 3x plus 2 plus 5. We write this here into f dash of x. That is here ddx of under root terms, that is here e to the power 3x plus 2 plus 5. ddx of e to the power 3x plus 2 plus 5. Therefore here dy by dx which is equals to, again we repeat this step. We find here ddx of under root e to the power 3x plus 2 plus 5, and we use here the formula ddx of under root fx which is equals to 1 by 2 under root fx into f dash of x. Similarly here dy by dx is equals to 1 by 2 under root e to the power 3x plus 2 plus 5 into ddx of e to the power 3x plus 2 plus 5. Up to this, these functions here as it is. So we write here 1 upon 2 under root e to the power 3x plus 2 plus 5 as it is. And then we find the derivative of this bracket by using the addition rule. By now that ddx of u plus v du by dx plus dv by dx. Similarly here ddx of e to the power 3x plus 2 plus ddx of 5. So we write here ddx of, we use here addition rule, ddx of e to the power 3x plus 2. We write this here e to the power 3x plus 2 plus ddx of is 5. So right here ddx of 5. Therefore here dy by dx is equals to 1 upon 2 under root e to the power 3x plus 2 plus 5 up to this as it is. So write this here up to this as it is. Then we find here the derivative of the bracket terms. We find here derivative of bracket terms. That is ddx of e to the power 3x plus 2. And by here we use the formula ddx of e to the power fx, e to the power fx into f dash of x. Similarly here, e to the power 3x plus 2 into derivative of 3x plus 2. ddx of e to the power 3x plus 2 is equals to e to the power 3x plus 2 into ddx of 3x plus 2. By using the formula ddx of e to the power fx which is equals to e to the power fx into f dash of x. By using this result, so we write here e to the power 3x plus 2 into ddx of this power, that is 3x plus 2. So right here ddx of this 3x plus 2 3x plus 2 plus, next we find here ddx of 5, and 5 is constant, therefore derivative is 0, because we know that the standard result ddx of k equals to 0 where k is constant. So we use this result, and here ddx of 5 equals to 0. Again we repeat this up to this here as it is. Then we find ddx of e to the power 3x plus 2 by using the formula ddx of e to the power fx, e to the power fx into f dash of x. Similarly, e to the power 3x plus 2 into ddx of 3x plus 2. Plus here ddx of 5, 5 is constant, therefore derivative is 0. Because we know that ddx of k equals to 0 where k is constant. Next here, again up to this step, as it is. So write this here In bracket here, in bracket, this e to the power 3x plus 2 as it is ddx of 3x. When now that the formula ddx of nx n. Similarly, ddx of 3x 3. ddx of 2 0. 3 plus 0, that is 3. 3 into this e to the power 3x plus 2. So right here 3 into e to the power 3x plus 2. 3 into e to the power 3x plus 2. That is e to the power 3x plus 2 as it is ddx of 3x, that is 3 by using the formula ddx of nx n. Similarly, ddx of 3x 3. 3 plus ddx of 2, 2 is constant, derivative is 0. So 3 plus 0, so right here 3. Therefore, here dy by dx, which is equals to this dy by dx, which is equals to here these functions here as it is. So we write here 1 into 3 e to the power 3x plus 2. So right here 1 into 3 e to the power 3x plus 2. So we get 3 e to the power 3x plus 2. And this is the required derivative of the function which is given in the problem, and a function is y is equals to under root e to the power 3x plus 2 plus 5. That is, in this way, we solve the second problem from board book, exercise 1.1 on page number 12. Next, again we solve one problem, that is problem number 3rd. So again, my request you, if you like my video, please subscribe my channel and press on bell icon. Next problem, that is the problem number 3rd. In this problem, again we find the dy by dx, or by differentiate here the given functions with respect to x. So here we find dy by dx, find dy by dx, find dy by dx. If y is equals to 10, so right here 10, in bracket, sorry, log of 10x by 2, log of 10 x by 2. We find the derivative of these functions or differentiate these functions with respect to x. Here function is given y is equals to log of 10x by 2, and we find here dy by dx. So first we write here the given functions. Again we write here the given function. Given function is here y is equals to log of 10x by 2. This is the given function. Differentiate this with respect to x. So we write here differentiate both sides with respect to x. Therefore, here ddx of y, so write dy by dx, which is equals to ddx of ddx of right hand side functions, and here we write the right hand side function. The right hand side function is log of 10x by 2. So we write here log of here 10x by 2. Therefore, dy by dx, which is equals to ddx of log 10x by 2. So again, we use here the simple derivative formula. We know that ddx of log fx, 1 by fx into f dash of x. And fx is here, fx is 10x by 2. Fx replaced by in this formula, fx replaced by tan x by 2 because fx is general functions. So fx is equals to here tan x by 2. And we use here the formula ddx of log fx 1 by fx into f dash of x. Similarly here 1 by tan x by 2 into ddx of tan x by 2. Here we find ddx of log tan x by 2. Again, we repeat this. We use here simple derivative formula ddx of log fx 1 by fx into f dash of x. fx replaced by tan x by 2. So 1 by tan x by 2 into ddx of tan x by 2. So we write here 1 by tan x by 2. So we write here tan x by 2. Tan x by 2. 1 by tan x by 2 into ddx of tan x by 2. ddx of tan x by 2. We write here this tan x by 2. Use tan x by 2. Therefore, here dy by dx which is equals to dy by dx is equals to this 1 upon tan x by 2 as it is. So write this 1 upon tan x by 2 as it is. And here we find ddx of tan x by 2. ddx of tan x by 2. So we use here again the simple derivative formula. We know that ddx of tan fx sec square fx into f dash of x. And fx replaced by here fx replaced by x by 2. Here fx replaced by x by 2. So here the derivative is sec square x by 2. ddx of tan x by 2 is equals to sec square x by 2 into ddx of x by 2. We use here indirectly chain rule. And for using this chain rule, remember the formula ddx of tan fx sec square fx into f dash of fx. Sec square fx into f dash of x. We use this result. And fx replaced by x by 2. Therefore, here sec square x by 2 into ddx of x by 2. So we write here sec square x by 2 sec square x by 2 sec square x by 2 into ddx of x by 2. ddx of x by 2. So right here x by 2. Therefore, here dy by dx is equals to 1 upon tan x by 2. 1 upon tan x by 2. So this can be written as 1 upon tan x by 2 can be written as cot x by 2. And when now that the formula for cot x by 2, that is cos x by 2 upon sin x by 2. When I add this in this way. Or this can be written as 1 upon tan x by 2 sin x by 2 upon cos x by 2. And by taking reciprocal, so we get cos x by 2 upon sin x by 2. Therefore, here we write cos x by 2 cos x by 2 upon sin x by 2 sin x by 2. Into, so right here into sec square x by 2. We know that the formula for sec x. We know that the formula for sec x. Formula for sec x is 1 by cos x. Similarly, formula for sec square x by 2, 1 by cos square x by 2. So we write here 1 by cos square x by 2 into, again we write here into, that is multiplied by ddx of x by 2. Here 1 by 2 is constant. So write 1 by 2. ddx of x, that is 1. So 1 by 2 into 1, we get here 1 by 2. Therefore, here dy by dx, which is equals to, here 1 cos x by 2, 1 cos x by 2 get cancelled. From this here, cos x by 2, here cos square x by 2. So 1 cos x by 2 get cancelled. Therefore here 1 cos x by 2 get cancelled, then here 1 into 1 into 1. So right here 1 upon 2 into sin x by 2. Here 1 cos x by 2 get cancelled. So 2 into sin x by 2 into cos x by 2 by using here the half angle formula, which is equals to sin x, because we know that sin x is equals to 2 sin x by 2 into cos x by 2. So we write here sin x by using the half angle formula, we get here sin x. And this is equals to, we know that the formula 1 by sin x is equals to cosec x. So we write here cosec x. And this is the required derivative of the function y is equals to log of tan x by 2. That is hereby differentiate these functions with respect to x and find here dy by dx. In this way, we solve here the third problem from exercise 1.1 on page number 12 in board book. So again, my request you, if you like my video, please subscribe my channel and press on bell icon. So in this way, today we'll solve three problems from differentiation, that is mathematics part second, exercise 1.1, page number 12. Okay.